Alright, so today we are going to talk about 7.5 Properties of Logs, Part 2. Remember, you do need to take these notes in your notebook and you will get a grade for them. I will check them when I see you again, so make sure you get a 100 and not a 0. Okay? Now, the first part of Part 2 is using logs that we already know the value for to estimate the approximate value of logs we don't know the value for. For example, we are going to use log base 4 of 3 that equals about 0.7925 to approximate the value of log base 4 of 192. Okay, so the first thing that we need to figure out is how many times 3 goes into 192. So all I'm going to do is I'm going to take 192 and I'm going to divide it by 3. Okay, so 192 divided by 3 is about 64. Or not about 64, it is 64. So now what I need to do is I need to take this value, 0.7925, and multiply it by that 64. So I'm going to take 0.7925 times 64. And when I figure out what that is, that's going to give me my answer. So I'm just going to get out my calculator, type 0.7925 times 64. Well, that tells me it's 50.72. So what that means is log base 4 of 192 is approximately 50.72. Okay, so we're going to do one more of these. For example B, we are going to use log base 4 of 2, which we know equals 0.5, to approximate the value of log base 4 of 32. So again, we are going to figure out how many times does 2 go into 32 by dividing. Okay, 32 divided by 2 gives me 16. So all I have to do now is take that 0.5 that we had originally and multiply it by 16. Well, 0.5 times 16, that is just equal to 8. So log base 4 of 32 is equal to 8. Okay, so first part of part 2 is approximating logs based on given logs that we already know. The second part of logs part 2 is using our properties that we talked about yesterday to solve equations using logs. Okay, so we have log base 6 of x plus log base 6 of x minus 9 is equal to 2. Now, I don't know how to solve a log when I have two logs on the same side. But what I do know how to do is condense those two logs together to make one log. And we learned yesterday that if we are adding, that means we are going to multiply what we're taking the logs of. So that's going to give us log base 6 of x times x minus 9. And that's equal to 2. Well, first thing I need to do is I need to simplify this x times x minus 9. X times x minus 9 is x squared minus 9x. Okay? Now that I know that, I can rewrite my log as an exponential. So I'm going to start with my base. I have a base of 6. Okay? 6 to the power of 2 is equal to x squared minus 9x. Well, 6 to the power of 2, that's just 36. So 36 is equal to x squared minus 9x. And as you can see, this is a quadratic function. And we know with quadratic functions, one side has to equal 0. So that means I'm going to have to subtract 36 from both sides to get that equal to 0. So I get 0 is equal to x squared minus 9x minus 36. And now I need to solve that quadratic. We know the easiest way to solve a quadratic is by factoring. So that factors to x minus 12 times x plus 3. And then to finish solving, we set both of those equal to 0. So I get x, oops, let me put that in a different color. We get x is equal to 12 and x is equal to -3. But just like before when we were solving logs, we always have to check our answer. So I have to plug both of those back in to make sure that they work. Okay, so the first one I'm going to plug in is 12. So that gives me log base 6 of 12 plus log base 6 of 12 minus 9 is equal to 2. 12 minus 9, that gives me 3. So I have log base 6 of 12 plus log base 6 of 3 equal to 2. Again, I can use those properties that we talked about yesterday, which means I'm going to multiply. 12 times 3 gives me 36. So log base 6 of 36 is equal to 2. And then I just need to check if that's true. So if I rewrite that, that would be 6 to the power of 2 is 36. And we know that's true, so this one checks out. So 12 is one of our solutions. Now we just have to check -3. So I'm going to do the same thing and I'm going to plug it in. Log base 6 of -3 plus log base 6 of -3 minus 9 is equal to 2. Now I can already tell that this isn't going to check out because it says log base 6 of -3. And we know we can't have a negative number there because our domain is everything greater than 0. So that tells me right here that this is not a solution. So the only answer that actually was a solution was x equals 12. All right, the next one we're going to look at is 2 times log base 7 of x is equal to log base 7 of 27 plus log base 7 of 3. Okay, so again, we are going to have to use those properties that we talked about yesterday. So the first thing I have here is this 2 out front. I need to get rid of that by bringing it over here and making it an exponent. So that's going to become log base 7 of x squared. And then over here, I have addition, which means I'm going to multiply those two things together. So that gives me log base 7 of 27 times 3, or log base 7 of 81. Now, if you notice, I have logs with the same base on both sides, so I can solve this log by getting rid of those logs. That leaves me x squared is equal to 81. Then I can just simply solve for x by taking the square root. And that gives me x is equal to plus or minus 9. Again, we have to check. And if I plug that back in, I can just look at it. 2 times log base 7 of x. If I plug in 9, it's going to work. If I plug in -9, it's not going to work. Okay? Because we can't take the log of a negative number. So my answer here is just positive 9. Okay. And then the last one we're going to look at today is log base 4 of 3x plus 2 equal to 4. Okay, so first thing I need to do is get my log by itself. So I'm going to subtract 2 on both sides, -2 minus 2, and that gives me log base 4 of 3x plus 2 is equal to 2. From here, I can just convert it to an exponential and solve for x. So if I convert this to an exponential, I'm going to have a base of 4. So 4 to the power of 2 is equal to 3x plus 2. Well, 4 to the power of 2, that just gives me 16. So 16 is equal to 3x plus 2. Then I solve for x. So first thing I'm going to do is subtract 2 from both sides, and I get 14 is equal to 3x. And then divide by 3. So x is equal to 14 over 3. Now, again, we always like to check just to make sure. So if I plug this back in to check, I'm going to get log base 4 of 3 times 14 over 3 plus 2 equal to 4. All right, now if I simplify that, These 3's cancel, and I'm left with log base 4 of 16 plus, sorry, not 16 plus 2. I'm getting ahead of myself. 14 plus 2 plus 2 is equal to 4. Now I'm going to do two things with this last step. Or not this last step. I'm going to do two things with this next step. I'm going to combine the 14 and 2, and I'm going to bring this other 2 to the other side. So that gives me log base 4 of 16 is equal to 2. Then if I convert that to exponential, 4 to the power of 2 is equal to 16, and that checks out. So my answer is, in fact, 14 over 3. Again, guys, make sure you take your notes in your notebook and you have them ready for me to check the next time I see you. Don't get a 0 for something as easy as copying down notes. Y'all have a great day, and I'll see you when I see you.